Warm welcome to everyone present here. Today I am here to discuss on the topic case study on experimental investigation on GGBS, that is ground granulated blast furnace slag on partial replacement of cement in high strength concrete. So this case study is all about usage of GGBS in replacement with cement in order to achieve high strength and high performance concrete. So over to you guys to explain about the case study which you have done in your previous project.
So our main objective is to create and design mix for M70 grade, which has been partially replaced with GGBS at different trial mixes and different proportions such as 0, 10, 20 and 30, 40 percentages. So where we could study about the strength and durability properties of concrete, and we could know more about the corrosion resistant property, and we could study about the fresh properties of concrete.
An introduction of high performance concrete is, and the high performance concrete is specially designed concrete to deliver the high durability, strength and workability when compared to conventional concrete, and it is achieved by optimizing its proportions and lower watt cement ratio and incorporating of mineral admixtures like GGBS, and it's usually refers to strength. 28 days of compressive strength is beyond 70 to 80 MPa.
So, normal consistency as per IS 8112/1989 specified limit is 33%. For normal consistency, we got 30%. And next, the initial time setting time, which we got is 58 minutes, and the final setting time is we got 270 minutes. The specific gravity is about 312, and the limit is 312 to 325. So it is between the limit and in limit. So the fineness of this limit is 5.67%. The soundness we got is 2 mm. And for the fine aggregate, we got the zone 2 zone we got, and the specific gravity of the fine aggregate is 2.63. The dry order density is 1802 kg per meter cube, and the silt content is 0.3%. The water absorption is 0.5%. For the coarse aggregate, the specific gravity is 2.64. The finest module is 5.85, and the water absorption content is 0.6%. For GGBS content, the specific gravity we got is 3.11, and the bulk density we got is 1800 kg per meter cube. Maximum dry density kilonewton per meter cube we got is 2.56 gram per kg, and optimum water content we got is 20%. Highly super plasticizer, color we got is light brown, and the specific gravity is 1.06.
Coming to mix design, for cement, we are using 502 kg per meter cube, and fine aggregate MSAT, we are using MSAT as a fine aggregate, and that is 526 kg per meter cube, and coarse aggregate 1150 kg per meter cube, and water is 201 kg per meter cube, and the proportion is 1 by 1.10 into this 1:1.10 is to 2.29. 1 refer to cement and 1.10 refer to fine aggregate, and 2.29 refer to coarse aggregate. And this is a table of mixed proportion for HPC, and we are comparing between normal ordinary concrete and 10% of GGBS and 20%, 30%, 40%. For normal ordinary concrete, we are using cement as 502 kg per meter cube, and fine aggregate as 556 kg per meter cube, and coarse aggregate as 1150 kg per meter cube, and water cement ratio as 0.29. Quantity of GGBS is 00, and slump value is 22.4 centimeter. And for 10%, cement ratio, cement reduced to 451.8 kg per meter cube, and fine aggregate is same, and coarse aggregate same. Water cement ratio is same, and quantity of GGBS is 10% we are adding, and in kg 50.2 kg, and slump value is 21.8. Then for 20% of say GGBS,
Okay, you can tell what maximum value you have got in which proportion?
in 40% we are getting maximum value. In that we are reducing cement ratio to 502 kg to 301.2 kg, and the slump value of this percentage is 18 centimeter, and we are using 208 kg GGBS.
So what we have observed during the test is, if you use 40% replacement of GGBS, you will be getting high strength as well as optimized value of slump value, and also high durable concrete. So the slump value is 18, and the compressive strength you have obtained is, next slide. So the compressive strength you have obtained 7 days strength of 50.2, 14 days strength of 61.8, and 28 days you have reached a maximum peak value of 77 Newton per mm square on using 40% of GGBS replacement in case of cement. Next slide please. So we have considerably the split tensile strength of the concrete also has been increased for 40% replacement of GGBS. So the optimized value is 40%. Next slide. And also flexural strength also improved for 40% of replacement. We have obtained 10.4 Newton per mm square after 28 days of curing.
As we come to the conclusion part, we are using GGBS as middle admixture for replacement of cement 40%, and the compressive strength is 77.0 Newton per mm square, and flexural tensile strength of the concrete with 40% of replacement is up to 4.86 Newton per mm square, and the flexural strength of concrete is 10.4 Newton per mm square. Thank you.